Hi, welcome to the Active Historian video presentation. Our project requires us to use a cheap device, preferably the Raspberry Pi, to create a consumer product for video logging. This enables the user, such as an elderly person, an ill patient, or young child, to create video diaries. This should allow them to record the video and automatically upload it to the internet. However, if there is no internet connection, it should be able to store it on the device locally. The device should be able to generate the sequence of files with time, date overlays, and be able to add basic transitions to the video sequence. Additionally, the device is required to use minimal buttons as possible, in our case, just one button. The device should also be able to be accessed, should also be able to be accessed using Windows 8, Android, and iOS.
Let's go.
Okay, so here's the Raspberry Pi running on a HDMI cable with a loop device used as its power source and its information source. Connected to it is a Realtek 802.11n Wi-Fi module, a keyboard, a mouse, and a webcam. This is also connected to a router with a 30 decibel antenna, which can be connected to a WAN. So over to the what do you call this? TV thing. Basically, the problem we have is the upload rate, the update rate of which the webcam is able to capture the video, and it's not really working at all. So VJ, explain why it's not working?
Basically, we have a CPU. The Raspberry Pi does not have enough CPU power to transmit the image data. The buffer is actually changing while it's actually receiving data, so we're getting split images of two different frames.
This is the Microsoft Gadgeteer platform running off the Fez GHI Spiderboard. Currently it's hooked up to an SD card reader, a multicolor LED which is currently on red, which signalizes it's not recording at all, simple button, a simple camera, and some Ethernet, as well as the power supply for it, which is running off a USB power supply. Currently, in the code, it's currently in a debug mode, telling us exactly what's going on. Unlike the Raspberry Pi, the image is currently uploaded quite frequently. So now if I push the SD card in, we will soon be able to get an SD card mounted debug message. So at this moment in time, if I was to press this button right here, the LED, as you can see, changed color to show that the image is being recorded, and with the red meaning it stopped recorded. So we're able to get back the debug. So we can see here, we allocated the string name to the picture. We entered a try and catch block to try and save the image, found the storage image, and we successfully saved it as part of the debug. So right now, on the SD card, there is the information from the webcam that we saved. From here we also need to, once we connect the Ethernet to a router, we should be able to get this uploaded automatically using the Azure accounts. That's the Gadgeteer platform. So we created a prototype on the Active Historian on an Android phone, which is the U8180 by Huawei. So if you click on the Active Historian, we link it with a Dropbox account. Currently it's using Wi-Fi, however this will also work with the 3G. It takes a bit of time, but it does work. So we now click Allow, which allows us to have access to the folders. So we now have a very simple interface where the user would just click Record. It changes and tells them it's recording. The moment we press Stop, it takes a while to say upload complete. And if we go over to the computer, which is over here, we can see down in the bottom, if you go into it, the computer notifies us that there's a new file added. We open this up, Apps, Active Historian. we can see, here's the video we just recorded.
It's recording the moment we press.
So yeah, it played fine. The audio was working. On top of this, we've also created an active historian media player instead of using one such as VLC. So this was created using Java. Currently, it's being tested with HD video, just in case we get an upgrade on the hardware we're using. So as you can see, it's currently playing flawless HD quality video. We can pause, continue playing, stop, go on next, plays the next video. Works fine. So this is just in case we do get a upgrade to a HD quality camera. But to keep it cheap, we kept this thing open source. The phone itself costs £30 and everything's working fine. That's it.
Alright, so this is the Raspberry software Raspbian. So basically what we did to make it as light as possible, we stripped down loads of the components in the Raspberry Pi, like we took out Scratch to make it as light as possible for it to work on. And right now my colleague Vincent is showing us something using the packages. So these are all the packages that we have, and
we uninstalled a few using the sudo apt-get remove command.
So that's what we did to remove like packages like Scratch, for example, and other components in the system that were not required.
So now we're currently also removing software that's not needed there. So you can see a list of all the software that we don't need at all. Therefore, we're saving up so much space. Now, currently it's removing unneeded components. It's looking at dependency trees so that we remove software which has a dependency that's not there. For example, we don't need Brasero, which is a piece of software which is used for recording to CD, considering the Raspberry Pi does not have a CD drive. So here we have the Android emulator, which is the most stripped down version of Android there is. On most Android phones that are shipped out of Android devices, it comes with things like the Google Play Store, which are actually installed as updates after the operating system is installed. So over to my phone. The current phone system, if you zoom in a bit, you can currently see it uses CyanogenMod 7. What CyanogenMod 7 is it strips the phone and makes it as close enough to the emulator as possible, so we have a faster experience. We don't have jargon. We don't have such unneeded applications, just as we removed from the Raspberry Pi. So in my case, I did not need things as accessibility options, since I don't have any accessibility problems. So using the CyanogenMod 7, we can customize our Android specifically for the user. So for example, zoom features, deaf people or people who have problems seeing or that are blind.
So how our code works, we have two classes, a main activity class and a video recording class. So our code starts in the main recording. The first thing that our thing does, it attempts to, it gets the Dropbox API, and it has the login page where the user will sign in with his username and password. If this is successful, it will then move onto the video recording class, where when you start recording, it will save the video on an SD card if there's no internet connection. And when there's an internet connection, it will upload that file onto the Dropbox. And then the user will be able to store all of his video logs onto Dropbox and then get that file and see all the videos that he's been recorded.
Okay, this is Xcode with the iOS app of Active Historian. I use a Dropbox API and a concise kit from an open source which contains functions and macros that help me write the code easier and faster. So what I did here was use the DB REST client of Dropbox to communicate with the account. So here we run the iPhone app. The account is already linked, so we don't have to sign up again. So syncing is done. So if we go to the folder, which is in the resources, there it is. So here is the folder with all the files on Dropbox. So let's say we want to add something on our Dropbox account and then check if it syncs. Let's say we add this picture. Done. And then while the app is open, we can press this button and resync. So we're going to do it again, same thing. So the syncing is done. So if we go again in our folder and find this download.jpg, so let's go to the folder. Okay, so here it is. It's there. So every time it syncs and finds if there are any changes, and if there are, it deletes or downloads the files changed.
Hi there, this video aimed to show the Android booting process. So we just went from the textual booting to the GUI booting. So within a few seconds you can see it went straight to the lock page. We now unlock this page and we go straight to our app. It took approximately 10 to 20 seconds to boot up straight into our app, which we will be not showing in this part of the video. Shutdown on the other hand on Android is pretty instantaneous, since this just requires the press of the power button, which disconnects it from the power. The aim of this video is to show the startup process of the Raspberry Pi. This may take longer than the Android system and longer than the Gadgeteer, which we'll be not showing due to the fact that Gadgeteer is essentially instantaneous. So at 1 minute 14 seconds we are close to going into the GUI, and then from there within a few seconds it should automatically launch Cheese using a script that we made. So at 1:27 it goes into the desktop. In a few seconds script should launch and give us Cheese. So a few seconds after we see Cheese starting in full screen mode. To turn off the Pi, it's really simple to just disconnect it from the main power source. This is because to start the Pi you just connect it to the main power source. However, the problem is this can have a bad impact on the SD card if it was to be in writing mode. Okay, so we're now going to benchmark the Android platform. As you can see here, we have a C program. It does something called the call-ats number. We are currently looping it about 3 million times. So we're going to compile this. So it finished compiling really fast. So we're going to run the program. So as you can see, the program started at 3:42 p.m. and it just finished. So the benchmark time for this platform is 25 seconds. So now we're going to benchmark the Raspberry Pi in the same way as we did the Android platform as well as the Gadgeteer platform, using the exact same file. So as you can see here, we start at 8:24 approximately, and we finish approximately 13 seconds after. In terms of benchmarking, we started the benchmark at 12:02 a.m. and it ended at 12:10 on the Gadgeteer. This is the longest we have seen this algorithm running on any of our platforms. So we can rule out using this Gadgeteer platform overall